Amazon Web Services is an unrivaled colossus of the internet age, providing the computational horsepower underpinning countless organizations. From Netflix to BMW, Disney to GE, Tinder to the CIA. It earns tens of billions of dollars a year. And if you've used the internet at all lately, you've probably used Amazon Web Services without even knowing it. Join us today as we enter the belly of the beast and take a sneak peek inside an AWS data center. In stark contrast to its cardboard boxes, vans, trucks, jet planes, and warehouses, Amazon prefers not to brand its vast portfolio of gargantuan data centers. But these monumental server farms are the very guts of the firm's wildly successful AWS, that's Amazon Web Services, division. AWS began life at a 2003 meeting in the lake house of CEO Jeff Bezos. The firm had just emerged strong from the dot-com bust, but Bezos' fast-growing retailer was having difficulties setting up and rolling out its own internal server capacity. A scheme promising fast, scalable server infrastructure was duly hashed out, and was swiftly identified, by the more enterprising young guns in the room at least, as a potential spin-off service Amazon could sell on to other companies. Fast forward to today, and AWS rakes in a whopping 60% of all Amazon profits. That's about $50 billion a year. How? By taking on other companies' tech problems in the cloud. If you're a startup in 2021, you no longer need to invest precious capital in vast banks of noisy, expensive servers and battalions of nerds to maintain them. You just rent time on Amazon's gear instead. That's the cloud. When you're busy, yay, you hire more gear. If you're quiet, whatever, you hire less gear. The actual gear in question is jealously hidden from prying eyes by Amazon. Even clients aren't allowed to poke around in the data centers they pay for, and their addresses aren't made public. But here's what we know. Take a typical site in Loudoun County, Northern Virginia. AWS is said to run at least 50 individual data centers in this region alone, covering several million square feet. Believe it or not, Amazon is planning on adding still more capacity in Northern Virginia. For instance, a 100-acre site near Dulles Airport the firm reportedly just shelled out a cool $73 million for. On entry to one such data center, let's say this giant nondescript box next door to a pet resort in Sterling, the first thing we notice is that security is the overriding concern for AWS. There's high fences, guards, and several layers of intrusion detection systems, most obviously cameras. When access is permitted to very limited people for very limited periods, two-factor authorization is required on at least 2 occasions during the visit. If a visit is sanctioned, this is extremely rare, visitors are accompanied at all times by at least one authorized member of AWS staff. Once this so-called perimeter layer is passed, the next stage of the data center is known as the infrastructure layer. This is where crucial systems like backup power, fire suppression, and most importantly, HVAC or air conditioning are situated. To maintain market dominance, AWS data centers cannot be allowed to fail ever for any reason. As such, water, power, telecommunications, and internet links are all designed with full redundancy. And keeping all those servers, as many as 80,000 in a single data center, running requires constant monitoring of ambient temperature and humidity to prevent overheating. If the worst should happen and a fire breaks out, a suite of systems involving water and gaseous sprinkler systems are rigorously maintained and good to go in a crisis. Past the infrastructure layer, and we're finally where the real magic happens, the so-called data layer. Security is even tighter here, with a secretive array of intrusion detection systems and even stricter review process for anybody going in or out. Even if something minor happens, for instance an internal door is held open slightly longer than usual, alarms are triggered. All access points are fortified with multi-factor electronic control devices. If a data breach, physical or virtual, is even so much as suspected, the relevant server is automatically disabled and shut down. These security systems are audited throughout the year according to a robust 2,600-point checklist supervised by external bodies. These external auditors can request access to anything in the data center, from humdrum logs to security footage or even the very cameras themselves. AWS staff are sometimes plucked at random from their shifts and interviewed about topics like the disposal of media, itself a process that's held to exacting and robust compliance metrics. Let's look at the hardware itself. In the midst of all this hypersecurity, it's maybe easy to forget that AWS data centers are fundamentally just enormous banks of servers. A typical AWS data center will hold anywhere from 50,000 to 80,000 servers, running on a combined 25 to 30 megawatts of power. It's said that AWS could quite easily double this size and make even bigger data centers. However, like everything Amazon-related, it's all a question of finely calibrated scale. Distinguished engineer and AWS VP James Hamilton told attendees at the company's reInvent conference in 2016 that beyond a certain point, increasing the number of servers and racks per center no longer lowers the incremental cost. At some point, the value goes down and the costs go up. And in our view, this is around the right number, Hamilton says of the data center size AWS usually goes with. Thrillingly, Hamilton employs the term blast radius to underscore the impact a failure might lead to in a much larger data center, hence the relatively modest dimensions. Still, 80,000 servers is plenty, designed to take in, according to Hamilton, some 102 terabytes of data each and every second. Significantly, the engineer also hinted that the bandwidth within the center is wildly higher even than that. Ever evangelists for vertical integration, Amazon have made great strides in streamlining and perfecting the servers themselves over the years. Unlike other co-location server infrastructure providers, AWS has a much clearer understanding of who will be using its hardware and for what. Removing this requirement to be versatile and generalist has enabled the firm to devise ever more efficient server architectures. When mundane software operations are translated on the hardware or even the very silicon of the chips, this can shave nanoseconds off of processing times, and at Amazon scale, that makes a big difference. Initially, AWS bought servers off the peg, as it were, from traditional suppliers. But steadily over time, the firm began developing its own single-depth servers, exquisitely optimized for airflow in AWS buildings running AWS software. AWS has even developed its own so-called Graviton chipsets since acquiring Israeli firm Annapurna. These Graviton chips, currently in their second generation with a third on the way, use the power-efficient ARM architecture. This represents a break from long-term Amazon partner Intel and its x86 architecture, and is said to give AWS clients 40% better price performance, essentially putting supercomputer-level power in the hands of regular commercial users. In terms of storage, a single standard-sized rack in an AWS center can hold 11 petabytes. That's 1,000,000 gigabytes of data on 1,100 disks. Multiplied, of course, by many thousands of times across many hundreds of data centers all around the world. AWS routers, here comes the science kids, can run custom ASICs or application-specific integrated circuits that support 28 ports with 25 gigabit Ethernet connectivity. This diverges, fun fact fans, from the industry-standard 10 gigabit Ethernet and 40 gigabit Ethernet networking speeds, but apparently, according to James Hamilton, offers economies of scale when paired together at 50 gigabit Ethernet. Networking between data centers, essential to provide security and backup for crucial client info, happens over Amazon's own private 100 gigabit Ethernet network, which connects the 25 international regions and 80 so-called availability zones across the vast AWS worldwide network. AWS even lays down its own private undersea cables. But back to our data center. Cooling is an overriding priority, and to minimize environmental impact, AWS, in particular in Loudoun County, Virginia, set out to use as much reclaimed water as possible. This stops the company hogging all the precious local drinking water, which would obviously be a PR nightmare. Loudoun Water, the local utility, are happy to provide this reclaimed water at a competitive rate. AWS pays serious taxes here, but it's worth noting that elsewhere, AWS has installed its own on-site water treatment systems. These prevent pipes clogging up with mineral sediment, which in turn causes costly hassle and delay. And if you think that's crazy, the company has even started developing its own power substations. All those servers use a fair bit of juice, so instead of waiting for slow-moving traditional power companies to develop infrastructure to keep all those all-important racks humming at all costs, AWS simply builds electric substations itself. Day-to-day operations within the data center are described by some ex-technicians as being akin to an ER department for computers. With that much hardware, inevitably things seize up, stop pinging, or require a reboot. Fault-finding and upgrading equipment is left to a small army of techs who follow rigorously drilled playbooks that cover almost any conceivable eventuality. Metrics are set by supervisors, encouraging teams to complete tasks quickly and efficiently. Some have complained that the working environment is cold, and it's certainly very loud. In the future, we can expect to see more and even louder AWS data centers come online. From early 2020, a new AWS center opened in the Northern Virginia area alone every 3 months, totaling around 1 million square feet in footprint, and that's just one area. All in all, it's quite the numbers game. What do you think? Do these vast data centers get the credit they deserve for underpinning so much of modern life? Let us know in the comments, and don't forget to subscribe for more super-sized tech content.